So here's another example where we want to combine this string of natural logarithmic expressions to a single logarithm. Now, this time, the negative coefficients, the positive coefficients are a little bit scrambled. And there's a couple of ways that you can deal with this. I'm going to take the kind of longer approach first that might be more concrete, might be clear about what's going on, and then I'll give you kind of a shortcut approach. Okay, so first with the longer approach. Keep in mind, I'm going to jot down these properties of logs real quick off to the side. So keep these properties of logarithms in mind. If you have log base b of m plus log base b of n, that's equal to log base b of m times n. If you have subtraction, log base b of m minus log base b of n, that's equal to log base b of m divided by n. What you might do first with a problem like this is first sort the equation. So collect the logarithms with a positive coefficient in front. So this is positive 1 natural log of x. So I'm going to leave that in front. And then you've got positive natural log of x plus 4. And then put the logarithms with a negative coefficient second. So minus ln of x squared minus 3 minus ln of 5. So I'm just rearranging the terms here. Now, suppose we factor out the negative. So this is natural log of x plus natural log of x plus 4 minus natural log of x squared minus 3 minus, I factored out the negative, so this will now be plus natural log of 5. So I'm saying move the terms with the negative coefficient to the back and then factor out the negative. Because what you can do now is apply this property of logarithms to combine these guys and to combine these guys. So this becomes natural log of x times x plus 4 minus, let me use another color here, natural log of x squared minus 3 times 5. And so now we have one logarithm minus another logarithm. So this is natural log of, this will go in the numerator, over this goes in the denominator. And the convention is to put that constant coefficient 5 in front. I'm going to move that. Doesn't actually make a difference, but this is the more conventional way to write that. So there's this expression written as a single logarithm. Now I promised a shortcut method. It is possible to take this strand of logarithms and go right to your answer. If you note that, okay, adding and subtracting, so when I combine to a single logarithm, that corresponds to multiplying and dividing. Any logarithmic expression with a positive coefficient, that bit is going to go in the numerator. So this has a positive coefficient, this has a positive coefficient. So the numerator is going to be x times x plus 4. This one has a negative coefficient, this one has a negative coefficient. So on the bottom, we're going to have x squared minus 3 times 5, which is equivalent to what we came up with here. So it's possible to go right to your final answer if you want to. And I'm happy for you to do either one, whatever makes more sense to you. If you want to just kind of sort it out with, okay, this has a positive coefficient, it goes on top. Because remember these negative coefficients, that corresponds to the negative 1 power, which is why the x squared minus 3 and the 5 land in the denominator. Or if you'd rather kind of sort things out step by step to see exactly what's happening, then you can solve it this way.